My name is Masinde Splendor from Kasawo, Islamic. We are going to do number 18, paper 2. It says, use the trapezium rule with 6 ordinates to find the integral of this function. When you are finding the integral of this function using the trapezium rule, we are going to first find the height, and the height is equal to the upper limit minus the lower limit divided by the sub-interval. But we were given ordinates. So to get the subordinates n, we shall say the ordinates minus 1 to get the sub-interval. So now we have our subordinate, which is our sub-intervals, which is 5. And we want to get our height, which is the upper limit, which is pi over 2, minus our lower limit, which is 0, divided by 5, which is our n. So our h is going to be pi over 10. This is what we have. From here, we are going to use the table. And in the table, we are going to have some values that are repeated and some values that are not repeated. Our y is going to be this function, the value you get when you input. And since we have a trigonometric function here in this function, we are going to have to change our calculators to radians. If we let our function to be y, which is this. Because there are some functions which are repeated and others which are not repeated. The ones which are repeated are going to be here, and the ones which are not repeated are going to be here. Our first value of x is the lower limit, and we put it here. To get our next value of x, we are going to add the lower limit plus the height, which is pi over 10. Then we add this plus the height, which is 2 pi over 10. We add this plus the height, it is 3 pi over 10. Then we have 4 pi over 10. And finally, we have pi over 2, which is the upper limit. Then here in our last part, we shall have the total. In the trapezium rule, the functions that do not repeat are the first one and the last one mainly. So your calculator has to be in radians. The first value here, when you start to input this function in the calculator and you put it for 0, our first function is going to be 0.5. We have 0.5, but since they want the answer to 3 decimal places, our table is going to be in 4 decimal places. We're going to put our value from 4 decimal places. So we add 0, 0, and 0. Then we also input this value to finish the value in this table. Here we have 1.00000. Then we add them up because they're the only ones that are not repeating. We shall have 1.50. Then we put this function, and we're going to write the remaining ones here, the remaining values.
Aynı number ya. Çizdi.
calculator, that the calculator has to be in radians, and this is the total of these values. Then we come and we estimate the integral. Is approximately, the formula is a half times our times the height, and our height was 5/10 into the functions that the values that don't repeat themselves, the summation of the functions that don't repeat, which is 1.5 plus 2 times the functions that repeat, the values, sorry, that repeat, now, since the question told us to correct to 3 decimal places, our answer is going to be 1.008, and this is the approximate value.
My name is from Kasawo Islamic School. I'm going to continue where my colleague has stopped. I'm going to discuss number 18b, which said that calculate the percentage error made in the approximation in A above. The percentage error, the trapezium will give us the approximated value, or which is the same as the estimated value. Now to get the percentage error in the approximation, the formula is error, percentage error is equal to error over exact value magnitude times 100. Now to get the exact value, to get the error, we first get the exact value, we subtract the approximated value. Now to get the exact value, we are going to integrate the function, which is integral from 0 to pi over 2, 1 divided by 1 plus cos x dx. We are interpreting this one in order to get the exact value. Now, we are going to integrate. Let us first integrate from. We are going to use the t substitution. T is equal to, let t equal to tan x over 2. When I differentiate both sides, I get dt dx equal to a half sec square x over 2. Now my dx is going to be 2 dt, but sec square x over 2, it is the same as 1 plus tan square x over 2. But my tan x over 2, it is t. Now dx is equal to 2 dt over 1 plus t squared. Now I substitute for dx is the function integral of 0 to pi over 2, 1 over 1 plus cos x dx is equal to, but from here I can first get the values of x in terms of t. From here, these are values of x, these are values of t. When x is 0, when I substitute for x is 0 here, I get my t as 0. When I substitute for my x as pi over 2, I get my t as 1. Now integral of this, integral of this from 0 to pi over 1 over 1 plus cos x dx will be the same as integral from 0 to 1 over, but remember cos x is the same as 1 minus t squared over 1 plus t squared times my dx, which is 2 dt over 1 plus t squared, which is equal to integral from 0 to 1, so be 1 over with the LCM 1 plus t squared. Then you get 1 plus t squared plus 1 minus t squared times 2 dt over 1 plus t squared. Now I remain with integral from 0 to 1. Simplifying, I'll get 1 plus t squared over 2 times 2 dt over 1 plus t squared. This one becomes I remain with integral of 1 dt, which is from 0 to 1, which is t from 0 to 1. I substitute for t equals to 1 minus 0. I will get 1. This is my exact value. My exact value of integral of 0 pi over 2 over 1 over 1 plus cos x, it is 1. Now I'm going to get my error because I need to have the error. The error E is given by exact value minus approximated value. Magnitude. Now my error is equal to exact value, which is 1 minus approximated value, which is 1.008. My error is now my percentage error. My percentage error is error over exact value times 100. The error is 0.008 over exact value, which is 1 times 100. This is 0.8%. This is the percentage error in approximating the function. Thank you.